Hi everybody, welcome to physics teacher class. So we are discussing laws of motion, Newton's laws of motion. Yes, and we have seen yesterday how to draw free body diagrams and how to write equations for that. Okay, so today we are going to discuss some more bodies and connected bodies and pulley problems also we are going to discuss. Listen carefully. So now let us consider another case. There is a surface. On the surface there is an object mass m1. On m1 another object is placed m2. On m2 another object is placed m3. Now this is the situation. Now let us draw free body diagrams for each and every body. Okay sir. Now first let me draw free body diagram for m1. Now tell me how many forces are acting on m1. Okay, so how many forces are acting? One is gravitational force. That one is equal to m1g. Okay, weight of the body. m1g I am writing fg, that is m1g. Next, as it is in contact with the surface exerts a normal force on m1. Let us take that as n1. Okay, next m2 is in contact with m1, yes or no? So m2 applies a contact force, normal force on m1 downward. So then in downward direction there will be one more, that is n2. Don't confuse here. n1 is by surface. Listen carefully. It is the normal by surface. Okay, n2 is by body m2 surface. Okay sir. Now this is the free body diagram of m1. Clear? So if you want to write net force, then what? These two are acting in the same direction. Therefore n2 plus m1g will be is equal to m1. That is the equation. Clear? Okay, as there is no motion, all are in rest, this will be the equation. Now coming to m2 now. Let us see body m2. On m2 how many forces are acting? This is a question now. On m2 how many forces are acting? Okay, one is the weight of the body downwards, that is gravitational force acts downwards mg. Okay, next m1 and m2 both are in contact. Yes, so m1 applies a normal force on m2 in the upward direction. That is equal to n2, because m2 applies a force on m1. How much? n2. That is the n2 by m1. Okay, n2 is by m2. Now m1 applies same force on m2, right? So that is. Next, is there any other force? m3. Yes, the surface m3 is in contact with m2. So m3 applies a normal force on the body in the downward direction. How much? Let us take that as n3. Clear? Now in this, what is n2? n2 is the force applied by m1. These two are balanced. These two forms action reaction pair here. Okay now. Next, what is n3? n3 is the force applied by m3. Yes, right. So if you want to write equation, what could be the equation? So m2g plus n3 is equal to n2. Yes or no? So these two are acting in the same direction, so we are adding, right. Now coming to m1 sir, sorry m3. What could be the free body diagram of m3? On this, as usual, gravitational force will be acting, that is m3g. Okay, next m3 and m2 are in contact. Okay, therefore m2 applies a normal force on m3, which is equal to force applied by m3 on m2. How much is that? n3. So in the upward direction, that will be n3, right Nana? Now n3 is the force applied by m2 on m3. Clear? Now write equation. What could be the equation? m3g is equal to N3. This is the equation, force equation. Clear? In this way one can draw free body diagram of any situation. Clear, Nana? Right. Now let us see connected bodies. What is that? Connected bodies. Means connected bodies means what? Okay, the bodies are connected with the help of a string or rope. With the help of a string or rope. Then these are called connected bodies. Clear? Now you can understand a simple thing. In this situation, string or rope has come, then there will be another force. What is that? Tension will come in this case. Yes or no? Right. First let us see a simple situation. Okay, this is a ceiling of a room. For the ceiling of a room, there is a string or rope. One end of the string is tied here. For other end, we just connect a mass M, so that the string becomes tight, so that tension will be developed. Now I want to draw free body diagram for M. Okay, free body diagram for mass M. Now tell me how many forces are acting on M? Two forces. Very good. One is weight of the body, gravitational force. Second one is, okay, there is no surface in contact with that. There is no normal force. Right, Nana? So only the thing is string. So string always pulls the body. So tension will be acting in the upward direction. Right, Nana? So this is that. Now T is equal to mg is the equation, as there is no acceleration. So now the tension developed in the string is equal to weight of the body. If you know the mass of the body, you can calculate tension simply. So how much is the tension? For example, if mass of the body is 2 kg, then tension will be is equal to 2 into 9.8. That is how much? 19.6 Newton is the tension developed in the string. Understood, Nana? So in this way one can calculate. Clear? Now let us see one more situation. In this situation, there is a ceiling. Okay. Now here is one string. A mass M1 is connected. Okay. For M1 there is another string and another mass M2 is connected. M2 is connected. Now let us draw free body diagrams for M1 and M2. Right, Nana? Very good. First let us draw free body diagram for M2. On M2, how many forces are acting? Two forces. One is gravitational force, which is equal to weight of the body. Second one is this string is pulling the body upward. Okay, let us take tension in this string as T1. So that is T1. So T1 is equal to how much? M2g. From this you can calculate value of T1 if mass is given. Right. Now free body diagram of M1. Okay. And now tell me what is that? How many forces are acting? One is gravitational force, that is M1g. Okay, na? Always gravitational force acts. Next, this string is pulling the body downward. Always string pulls the body. Yes. Then how much is that? T1. The tension in this string taken as T1. Okay. And next, this string also pulling the body in the upward direction. Okay. This tension, let us take T2. As the strings are different, tensions also will be different. And one more thing, here in these all bodies what we are taking is string mass is negligible. Mass of the string is negligible. Okay, na sir? So massless string is a consideration. So a string also has mass, but for our simplification we are neglecting it. So adding the string mass also we will be learning how to calculate that later. Okay, na? Now this is how many forces are acting on this totally? Right, 3 forces are acting. Okay, in M2, on M2, 2 forces are acting. Now tell me, in these two, which are action reaction pair? M2 and M1, you observe carefully, which is action reaction pair? T1 is action reaction pair. Yes or no? Very good. And now come on, what is the equation? M1g plus T1 is equal to T2. From this you can calculate T2. Okay, here already we have calculated T1, right Nana? So therefore T2 can be written as what? M1 plus M2 of G. Finally we will get the equation. Clear? Very simple. First the thing is you need to identify how many forces are acting on it and their direction. Clear Nana? Right. Now let us see one more situation. Okay. So in this situation the bodies are on a horizontal surface. The bodies are on horizontal surface. Let us take it is M. Okay. Now this is the string. Okay. Next on this string I am applying a force F on the string. Okay, it is connected to the string up to this. Let us take on this string I am applying a horizontal force of F so that the body is accelerating. For this, what could be the free body diagram and what is the equations? Now come on. Okay, now in this case, in this direction how much force is acting? That is equal to T, that is equal to F. Simple. Okay na? T that will be is equal to F as there is no mass for the string. Understood? Right, only this is the force acting horizontally. I am not drawing vertically because there is no motion along vertically. We no need to draw. Then what is that? F is equal to simply ma. Then the acceleration is equal to F by m. That's it. Very easy situation. Yes. Now let us see another situation. Now this is m1 and a string is connected m2. Now on m2 I am applying force. There is no string. Understood? Directly I am applying force on m2. Now observe carefully. This is the string. So I mark with red. This is the string. Okay, when you pull this m2, m1 also comes along with the m2. Yes or no? Yes. If the distance traveled by m2 is x, m1 also travels the x distance. Okay, therefore if you treat this as the system, okay, the acceleration of the system is taken as a. That means acceleration of m1 is equal to acceleration of m2. Understood? You connect one more body, that acceleration also will be same. Understood Nana? Right. Now how to calculate acceleration of this system? Very simple. Now acceleration of the system is equal to net force acting on the system divided by total mass. Total mass. Okay, that is equal to what is the net force acting on it externally on the system? F divided by what is the total mass of the system? m1 plus m2. In this way you can calculate directly without free body diagram. You can calculate directly the acceleration. Okay, now how to calculate tension in the string? Okay, and now see that first let me draw free body diagram for m1. On m1 horizontally how many forces are acting? Horizontally how many forces are acting? Right, only one, that is a tension. Yes or no? There is no other forces horizontally. So from free body diagram, T is equal to m1 into a. Yes or no? Right. So you can calculate tension from this because acceleration is given, that is equal to m1 f by m1 plus m2 if the values are known. Now what is the net force acting on m2? See that free body diagram for m2. On m2 this is the applied force. String will be pulling the body this side. Yes. So what is the free body diagram? Sorry, net force F minus T, that is equal to m2 into a. Understood now? So in this way we can calculate what are the things need to be calculated. Clear? In this way we need to draw free body diagram. Acceleration of the system will be same. That means acceleration of both the bodies are equal. How much is that acceleration? Directly you can calculate what is the applied force, net force by total mass. Clear sir? Right. Now let us see. You can connect any bodies. Now let us see three bodies, suppose m1, m2, okay, m3. On this m3 you are applying a force F, suppose. Now this is a string, this is another string. So in this let us take tension T1, in this let us take tension T2, or you can take T1 here, T2 here, that's your wish. Okay, now tell me what is the acceleration directly. Very good, F by m1 plus m2 plus m3. See how easy. This is the acceleration of m1, acceleration of m2, acceleration of m3. Easy or not? Yes. Now what is the free body diagram of m1? Very simple. On m1 only the force tension is acting, so that from this you can calculate tension T1 is equal to m1a. Completed. You got T1. Okay, what is the tension in this string? If they ask, T1 is equal to m1 into a. Simple. By seeing the diagram you can tell. No need to draw free body diagram also. Okay, what is the tension T2 value? For that you draw free body diagram for m2. That is what is the forces? T2 this side, T1 this side. So that T2 minus T1 is equal to m2a. Okay now. So in this we got m1, T1, acceleration is there. Directly you can calculate T2. Here why I have written T2 minus T1? Because I assume that acceleration is this side. That's why T2 is greater than T1. That's why T2 minus T1. Now what is the free body diagram of m3? Very simple. F and T2. Yes or no? Two forces horizontally. Then F minus T2 is equal to m3a. How simple is the physics? Application of physics. Yes? So in this way, whatever may be the problem, you can solve very easily on your fingertips. Right, Nana? Yeah. Now let us see pulley problems. Pulley situation. Okay. That is simply, first let us take Atwood machine. What do you call it as? Atwood machine. Actually, these Atwood machines are used to calculate acceleration of a particular place. Okay. Now see Atwood machine, it contains a pulley, frictionless pulley and massless pulley. What is our consideration is frictionless and massless pulley. That is fixed somewhere. These pulleys you might have seen on cranes, edges of the cranes, and in old days village wells, on wells of the village. Okay now, so village you can see that pulley, right? It looks like a wheel. Okay, now a thread or rope is passed over this. This is the rope passed over this. Okay, Nana? Right. So bucket is connected here and you will be pulling in this way. So here instead of bucket we are taking a mass m1 and here another mass m2 is taken. Our consideration is m2 is greater than m1. Okay, if m2 is greater than m1, m2 will be moving downward, m1 will be moving upward. Yes or no? If you pull this down, this will be moving up. Yes, and as long as the string is same, okay, length of the string is constant. Here length is constant. Which length? Length of the rope or string is constant. It is inextensible. It cannot expand or contract, and we have taken its mass is less, therefore acceleration will be same. Okay, acceleration will be same along this. Then acceleration of m1 is upward a, acceleration of m2 is a downward. Right, Nana? Now let us draw free body diagram of m1. Very easily you can tell. How many forces are acting on it? Two forces. One is gravitational force, which is equal to weight. Second one is tension T. Now write the equation for that. It is moving up, so T is greater than, so T minus m1g is equal to m1a. Yes or no? Right. Now from second body, free body diagram for second body, what? m2. How many forces are acting? Two forces. One is gravitational force, which is equal to weight of the body. Second one is tension, that is pulling up. Always tension pulls the body. Already we discussed in contact and non-contact forces itself. If you did not see that video please. Now the body is moving down, so that m2g minus t is equal to m2a. We got two equations. Okay, we need to solve for a and t. Okay, we are going to calculate a, acceleration of the system, and tension in the string. So to calculate two things, we require two equations. We got it. Let us solve for tension first. Okay, na? So that means we need to eliminate a from that, right? Nana? And now see that I can write this one in t. From these two equations, what I am writing is t minus, okay, m1g is equal to m1a is there. Okay, now in place of m1a, I can write m2g minus t by m2 is equal to a. Can I write or not? From this equation, m2g minus t is equal to a. Right. m1 of m2g minus t by m2. From this we can calculate t value. Right, Nana? So another thing, if you want to calculate a value, eliminate t from these two equations. So from this m2g minus t value, what can I write from this? m1a plus m1g. Yes or no? m1a plus m1g. Understood or not? T is equal to what can I write here? m1a plus m1g. This t value I am substituting here. That is equal to m2a. Okay, now? And now simplify this. m2g minus m1a minus m1g is equal to m2a. A terms send that side. Therefore, m2g minus m1g is equal to m1a plus m2a. Got it? Yeah. Now you take common g, then m2 minus m1, that is equal, you take common a, here m1 plus m2. Therefore a is equal to what can I write? m2 minus m1 by m1 plus m2 of g. Yes, simple. This is a simple formula to calculate acceleration of the system, right? Now here we have taken m2 is greater than m1. Okay, so that m2 minus m1. If m1 is greater than m2, m1 minus m2 by total mass into small g. Okay, now you calculate tension here. Okay, so or else instead of doing this, okay, instead of doing this, you substitute a value in any one of the equation. Let us substitute in this equation. Okay, now or in this equation, t minus m1g is equal to m1 of a is m2 minus m1 by m1 plus m2 of g. Okay, now send this side t. T is equal to m1 g of m2 minus m1 by m1 plus m2 plus m1g. Okay, na? So let us simplify this. If you simplify this, what are you going to get is that is equal to, so let us take m1g common. Therefore LCM will be m1 plus m2. Yes, so this is m2 minus m1 plus m1 plus m2. So these two gets cancelled. This is 2m2, right? So therefore t is equal to 2m1 m2 by m1 plus m2 of g. That is the equation for tension. Okay, na? So we got two things, a and t from this. This is Atwood motion, connected bodies and Atwood motion, right, na? So in this way you can calculate acceleration of the system and tension in the system, right? So more things on this Atwood motion we will discuss in the next video. Thank you very much.